good evening. To our tonight's stream, which is all about the XT Compact Flash Lite card, one of which I already have here. I assembled this a couple of weeks back, and this is for the uninitiated. This is a homebrew card made by Sergey Kiselev, and yeah, he did this already quite a bunch of years back, and there are other variants similar to this, and it's a card for an old PC, 8-bit ISA slot down here, and it allows you to plug in compact flash cards, which have been since superseded by SD cards and micro SD cards, but something like this. And what this does is basically give you an alternative to old failing hard drives. You can just plug it in, pull it out, put it in a card reader and put some software on there. What it also does is it has a ROM on board which extends the PC's BIOS and lets the PC use hard disks, not only compact flash cards, but hard disks bigger than 500 megabytes, because the old IBM PCs, they had a limitation because 640 kilobyte of RAM and 500 megabytes of hard disks will be enough for everyone, which turned out not to be that accurate a prediction. So nowadays, when you want to resurrect an old PC, something like this can be an option. It's not always necessary, but it is convenient. It's also not the fastest solution, but yeah, it's easy. It uses relatively few components, as you can see, and yeah, there's basically only 3 ICs on here, plus the EEPROM and a few dip switches, bypass capacitors, and a couple of resistors, and then of course the connector, or the compact flash connector, and that is actually the most difficult part on this device, because you can have a look here. It is it has a lot of pins, and it's basically a surface mount component. And I did one of these 2 years back, I think, but I never managed to solder the compact flash connector in a proper manner. It wouldn't quite work because my soldering skills weren't good enough, and I'm sorry if the iPhone camera shows some weird stuff here, but I still don't have another camera, but I think the iPhone works pretty okay for now. Anyway, I wanted to solder another of these. Not sure what I'm going to do with the second one, but I noticed that a few people on the forums where we ordered these PCBs in a batch so that we can save on money, they also had problems soldering the connector. If you're not experienced with SMD stuff, it can be tough at times. So today I want to show my technique, and you don't need very expensive equipment. You need a bit of practice and a few tools, but basically it's not that hard. So yeah, let's put this aside, all the stuff that we don't need right now. These are the components, the small components. We put them aside, we will use them later. What we definitely need is the compact flash slot or socket, whatever you call it. The ICs go also to the side, and we need the PCB, which is in here. And this time I chose black PCB because I think it looks nice, and you can also see the pads pretty well, I think. This one here has a bit of dirt down there, but we will wash it anyway in alcohol later when we soldered more or less everything. And yeah, I think we should start with the connector itself, because it's the main thing of the show. The rest is actually pretty simple. And if this doesn't work, then we can give up, more or less. It actually has some pegs on the bottom. I'm not sure if you can, yeah, you can see it here. Those pegs near the holes, they will fit into those holes here in the PCB. And you can even put a hex screw or hex, a normal screw with a hex lug nut on here to make it hold even better. First time I did this, I was a bit naive and I just tried to solder every pin here, but that's almost impossible. So what I did last time instead is I pre-tinned with solder the pads and then used a lot of flux. And for the flux I used this one here. This is, but you can use different flux, but this one works really well. This is some kind of very honey-like substance. It's of course some kind of synthetic resin, colophonium style flux. It's, from the consistency, it's really like honey. This one here is by company Emil Otto from Germany. But there are different ones, like maybe you know the Louis Rossmann streams. He uses Ampex flux, which is similar from its consistency and works equally well, but this is a German company, so I was able to get this easily. They sell this in syringes, and I already did a couple of projects with this, and I went from, I think, 7 milliliters down to 6 or something. So it's, yeah, you can do a lot of projects with these. They're not cheap, but for one project it will be just a couple of cents worth of flux that you're using. And it's a bit messy, that's why I keep it in this bag. Of course you have to use your air filter if possible, or open your window really wide, not to inhale the fumes, which are not the best, of course. Yeah, so we will use that, and I have two different solders here. One is 0.7 millimeters, the other is, I think, 1 or 1.2 millimeters. They are both with a flux core, so additional flux in there as well. The smaller one is probably enough here. This one gives bigger blobs sometimes. Also, we have our Chinese trusty T12 soldering station, which is compatible with the Hacko irons. But you can use any iron that you like. The beep says we are at temperature, which I set to 350 degrees. I'm gonna put the lamp a little bit to the side. I'm gonna see if I can make myself even a bit louder, but if I pull up the gain too high you will probably hear a lot of noise, so give me some feedback if there are like too much noise in there. Okay, we've got the PCB here, we've got the solder. I'm gonna pull a nice long string so that I have enough space, and I found a little SMD capacitor. I'm not sure where this is coming from. Probably the last project that I did. Teeny tiny thing. And what I'm gonna do now is clean the iron. I'm gonna put it here so you can see a little bit. Clean it in this brass wool, and then I'm gonna wipe down here and see if the solder takes onto the pads. And I'm probably going to put some flux already on there, because as you can see I'm getting a lot of bridging there. So we're gonna put on some flux and make it spread evenly over the pads. Look at this, it's a mess. But that doesn't matter. The flux will liquefy as soon as it's heated, then it will vaporize and produce some fumes, which you should not inhale. And the flux works against the solder so that the surface tension of the solder pulls the solder onto the gold pads. And then I'm just swiping up and down, and once I see that there's not enough solder there to mix anymore, I'm gonna wipe down some more. So pre-tinning was pretty nice. So now we already have some solder or tin or whatever on the pads, which helps to attach the compact flash slot. And if you have enough flux, there will be no bridging at all, actually. It will be nice and clean. We'll have a look in a second. Of course, always clean up your iron. I'm going to put the iron to standby now, because we will not need it for the next couple of minutes. Let's have a look. So this, let's take the light up here. This is what it looks like now. It's pretty dirty and sticky. So we should clean this up before we put the compact flash socket on there, because otherwise you will have flux underneath. If I put this now on, that will be pretty messy. You don't need to clean the flux, it's not conductive for us, so, but yeah, of course it's not the nicest thing. And for cleaning, we will take something off the desk. We take a nice white bowl, put the PCB in, and we will break out the alcohol, not for drinking, no. This is isopropyl alcohol. It's, I think, 99% or something. It's pretty pure, for sure. This whole bottle lasts me always for a year or even more. It lasts for quite a bunch of projects. So we are gonna pour a little bit in, so that the PCB is a little bit covered, and it dissolves these kinds of flux very nicely. Another thing that you should have, an old toothbrush is already enough for this, but on Amazon or some other places you can get a bunch of anti-static brushes for really cheap. They are like €2 for a pack or something, shipping included, so you can really buy just some anti-static brushes. Not sure about the anti-static properties, but as long as the PCB is not populated, that doesn't even matter much. And I didn't have any problems with those so far. You can reuse the alcohol. Of course, it's also evaporating, so if you leave it overnight it will be probably gone, but it will dissolve the flux, so at some point it will get pretty yellow and it will stain the PCB more than it will clean, so you have to replace it every once in a while doing a project. And the whole bottle costs a few euros only. If you buy it, I bought it in a pharmacy, and that pharmacy has very cheap prices for this. They also sell it in smaller bottles, but they are actually sometimes even more expensive because they have to fill small bottles with less of the alcohol, etc. Alright, so this is now relatively clean. I can feel some slimy residue, so it's not completely washed off, but relatively. And I might just step out to get some tissue. Let me do that very quickly. Alright, here I am. Very gently wiping it down. This will also clean all the gold contacts again, which makes soldering easier and make sure that, yeah, I mean, in the end we will give it another washing because there's also flux in the solder, so I'm gonna put this to the side. And we'll have a look, and it's actually looking pretty okay, I would say. Coming a bit closer here. So no solder bridges. You can see slight differences in here, but that's mostly, I think, due to the camera. It actually looks pretty okay. Yeah, the thickness is a bit different between some of the legs, but that's okay. Now we can try to actually solder everything on there. This should actually be enough to make electrical contact. So I'm not going to add any solder. What I am going to add is more flux again. This will help avoid bridging between the pins. Last time I didn't need to repair any bridges. As I said, it really, you don't have to take too much solder, and but you can almost never have enough flux. Hello Martin, thank you for the €2 donation. Yeah, definitely get some good flux. It's that's something that I picked up with the Louis Rossmann videos. He's famous for splurging insane amounts of flux onto the PCBs. I mean, he's earning his money with PCB repairs, so that's fair enough. But also for us hobbyists, I think it's pretty neat, and that made all the difference to me, definitely, to have flux. First I thought I might need a hot air station for stuff like this, but actually for this particular project the iron is enough. One of the other projects, the Gravis ultrasound clone, there were a couple of what was it? I think tantalum capacitors, SMD tantalums, and their footprint was so small I couldn't get there with the iron physically. So there you would actually need a hot air gun to melt the solder. But for this flux and this thing here, the iron is just good enough. So I'm gonna carefully wipe down, or probably just heat up the pads to make the solder melt, and then the legs will automatically attach because heat will be transferred throughout the pin from the pad. And if there's any bridging, you can add more flux and just heat up the pad again, because the solder always wants to flow into the direction of the heat. So if there's a bridging, then you try to heat only one pad and it should flow to that pad. Of course, we will perhaps also need to test this card today. My current PC doesn't need that because its BIOS can actually use larger hard disks. But we can still see if the BIOS is visible, and we can see if the CF card can be read. So we can probably test the card as well. Not sure if it will collide with the built-in IDE controller or something, but we'll see. So I'm going over all the pads a couple of times. There's still plenty of flux there. So, oh, it's getting hot on the bottom. As I said, 350 degrees Celsius I'm using. I think that's pretty okay temperature. It depends if you're using lead-based solder or non-lead based. Here in the EU, you basically, or at least in Germany, you can't buy any lead-based solder anymore as a private person. As a company, you can for repairing stuff, which I think is a bit weird, because I think hobbyists will probably use less flux than any company. And especially for hobbyists, the lead-based flux is usually, the lead-based solder is usually much easier. And the problem with the lead is only when you start recycling this stuff. During the product's life, it's actually not a big problem. The problem is when you need to get rid of the stuff. And at least the hobbyists, they will throw away very little. I mean, we're trying to keep this stuff running for half a century, even more. But that's how it is. So this is already sticking pretty good. There are two little tabs here and there, which you can put a blob of solder on to make it stick even better, because this is where the mechanical stresses will appear. So I'm going to heat up the gold pad right next to it and feed a little bit of solder in there. And heat it up, heat it up, heat it up. And there we go, it's done. Same on the other side, heating up the pad and the tab. Will take a little while because it's a lot of metal. And there we go, you don't need tons of solder there. It will cool off and pretty decently hold itself in place. Okay, luckily Sergey is doing a great job of designing PCBs, and all the resistor values are actually on here, so it will be easy to populate the board. Alright, the CF connector is done. I'm not going to clean the board just yet, because this here can be washed away soon and we will get lots of flux on the backside as well. But I will switch to the slightly thicker solder for the through-hole components. Both are, this one lost its badge, but both are Stanol tin 60%, lead 40% solders. I still got a little bit of a stash. As I said, not available in Germany anymore. Now you need to use lead-free solder, and it's a bit different. Let's say it's different to solder. If you are starting off with lead, it's probably fine. If you learned with lead-free, with leaded solder, it's probably a bit difficult. Let's do the resistors, I think, first. Pour everything out. And I must admit, I am not someone who learned how to read the color codes. So I'll pull out my trusty MK328 tester, which is a great tool anyway. And we're just gonna pick one of the resistors. I'm thinking about where I put my snips. Sergey did the footprint of the resistors here so that you have to really bend the legs very close to the resistor. Just have a look. This one is a red, blue, turquoise or something. 5.5 kilo. 5.5 kilo or 5.6. Here we have 5.6, so that's probably correct. With 10% or 5% accuracy, I'm not sure. Let's put that in here. Let's put in, I think we only have, 4 populated, and 1 is unpopulated. Okay, Martin says you can still get leaded solder here in Netherlands, for now at least. Yeah, that's the idea. I know that there are some countries, and I probably should import a little bit. I mean, I have 1 full spool of the 1.2 still left, 250 grams. Because actually it's also pretty expensive, right? So a big spool of solder can cost quite a bunch of money. And I'm not going to buy 1 kilogram, I think. Oh look, I did this not very well. Need to be much closer. For people who do not know, Sergei Kiselev has been doing a lot of cool projects. He also made the Micro 8088 PC basically, which was the template for the new XT, which gained some popularity due to some LGR video. But the design is basically, yeah, the original was Sergei's stuff, but it was more or less a classic PC design on one ISA card using an ISA backplane. So he basically designed his own PC. He has some other fun projects. You should definitely check it out. Yeah, his website is malinov.com. So this one is a 1K. And you can see how lazy I am. I'm really, let's put the iron to sleep. Really don't reading the color thingies. If I were to do more resistors or more projects, I would probably learn the codes at some point, but not right now. This should be the 10K resistor, I think. I think the other one is unpopulated, but let's see. Let's see. Oh no, this is the 470 ohms up here. Okay, okay, the 10K is unpopulated. Yeah, that's fine too. Okay, we've got all the resistors in. So now we're gonna solder them. Necrover, good evening. Yeah, hi. Welcome. I already did the CF slot, but you can watch that in the after the stream. You can watch it on YouTube if you want to see that, and we still need to clean and test it. Now I'm doing the resistors. Come on. Come on. Why don't you want to heat up? No, now it's going. Come on. Something is eating my heat. It says 350 degrees. So this didn't turn out nicely. I have to redo this. Yeah, the footprints definitely could have been bigger, but it's okay, it works. So although it's called the XT CF, it's possible to use it in any PC with an ISA slot. I have been using it in a 386 even, but I also have a 16-bit IDE controller in there as well for speed. But it was to expand the BIOS to the XT IDE BIOS functionality with the larger hard disk capacities, etc. So yeah, it's definitely a very good idea to put this in an XT, but 286, 386, even many older 486s can have advantages by using this for larger disks. For example, my 486 right now has a BIOS from 1991, but it's actually a Microid research BIOS, and they actually invented the remapping of IDE cylinders and sectors and whatever to address hard disks larger than 500 megabytes. So I actually don't need it in the 486, but the 286 and 386, they actually need it in the BIOS, so that I can use like 1 gigabyte of compact flash. You can use some software in the boot sector as well, but I never had any luck with that. The nice thing about this is that it's a plug-and-play solution. The only problem is that you need to program the EEPROM, and in theory you can do this on the board. There's a switch which tells which enables writing, and there's also a tool to flash the EEPROM with the firmware. However, my Microid research BIOS, if it sees that there's an empty ROM, it actually puts RAM over that spot, and you can't write to it. You can write to it, but it will not be written to the EEPROM. It will just be written to RAM. And that was a bit of a problem, but then I got a used EEPROM burner, which is run over the parallel port from a friend. I also made a video about that. And then I could actually write the BIOS. So that was quite interesting. Okay, let's do the socket and the capacitors and ICs, I think. The socket is actually pretty high quality. It's one of those precision sockets, and this one here looks wonky. Yeah, they are very, very tiny, the footprints. Necroer says, I made a video about XT IDE software too, however don't have an 8-bit XT IDE adapter. Yeah, well, now we have one here in this video. I don't have any XT machine, and with 16-bit I use a network card and a normal IDE controller. Yeah, that's definitely a possibility. Everything that can take a BIOS chip can be used actually. The 8-bit XT IDE is only needed if you really need to run XT. That's true. But it's also nice to have this in there, to have something where you can swap in and out the card for transferring data to and from your modern PC. And to have the extra BIOS here. So that's also nice. You can have your internal hard disks and stuff, and the 16-bit fast controller. And this here gives the ability to use larger disks and to have removable media, basically. Of course, you have to turn off the machine, but yeah, that's normal. All right, let's talking more soldering, I guess. I like doing ICs and sockets because you just have to do one leg after the other. So this looks pretty okay, I guess. Also, this is very good for practicing soldering because you do a lot of the same stuff over and over again. And if I look at my current PCBs compared to 2 years ago or 2.5 years ago when I started, I definitely got better. My technique got much better. So as always, practicing is key to getting good, so to speak. So I wonder, we have now like 7 people or something in the chat. Quick poll maybe, I'm not sure if I can do something like that, but maybe just raise of hands. Who actually owns a retro PC and who is just watching out of curiosity? Necroware prefers through-hole PCBs if possible. Yeah, I thought the same, but the SMD also has its advantages. It's if you're good at it, it's actually faster. You don't have to do the snipping and all this stuff. I have somewhere here, oh sorry, where is it? Here it is. One of these SMD training kits. You can get them for like €2 or something. It looks a bit weird because there's dust, a lot of dust on it, because it was lying for weeks on my desk. And you have rows of, it's actually supposed to go like this. Let's put the lamp up. Rows of smaller and smaller components. You start off with 1206 size, then 0805, and you get smaller and smaller. And there are test points down here, which you can test with your multimeter, and it should have the okay, these are capacitors, but there are resistors here. You can test the resistance, and they should of course add up, and that's pretty nice. And yeah, the training board is nice, that's true. And here's actually a very nice circuit which does something. So you have to solder 2 ICs, and the worst thing were the diodes, because the diodes, again, the footprint is actually wee bit too small, and I destroyed one and had to replace it. Everything else was fine, and also hot air helps if you want to have it aligned perfectly, because with hot air you just heat it up and the component aligns itself. That's total magic. And there's actually a very nice circuit here which blinks, and it uses a counter, and yet there you can see that you actually did a job that was okay, because it works. So I can definitely recommend them if you want to get started on SMD soldering. They are like €2 each, delivered. Yeah. GRR3 says, hello, speaking of through-hole mounted chips, what is the best way to safely remove them if they aren't socketed? You're talking about desoldering. I know that there are desoldering guns, but they are a little bit more expensive. I think you can get some for €50, but the better ones are more expensive. I simply use this. I use flux, my tacky flux, put some on there, and use the pump. The problem with the tacky flux is it helps with the desoldering, but it also gets stuck inside the pump. But these are like €2 or €3 each on Amazon, and they last for, the last one lasted for 2 years, so every 2 years a new pump, I think it's okay. And you just load them like this, heat up the leg, and then you press and everything goes flying, and it sucks up the solder. It actually works, but the best thing, if you need to desolder like 200 legs at once, you might want to invest into a desoldering station, which has its own heating element inside. So it's basically an iron with a pump attached. I'm gonna check up on the socket here, and it looks good, I think. Martin says, I own too many retro PCs. Okay, that's nice. I guess quite a few people here do. What do we do next? My soldering station is going to sleep. I used to use my pump a lot, says Necroware. I still do sometimes, but once you use the desoldering station, you won't look back. Yeah, I believe that's true. But so far I didn't want to do the expense. But it's definitely on my shopping list. But I don't have to do that many desoldering tasks. There is one board that I own, which has a broken ISA socket. And desoldering that will be a pain. And for something like that, I would definitely buy a desoldering station. The ZD915 desoldering station is relatively cheap, says Necroware. I can really suggest it. Yeah, I saw that. That's very common on eBay. Are we going to do the ICs now, or shall we do the bypass caps first? Probably bypass caps. So these big ones are the 10 microfarads down there. Double checking, but I think this should be safe because they are the only two big ones I have here. And these are the bypass. Martin says, I bought the 10 microfarads, yeah. I bought the cheapest desoldering station, it's okay, but clogs up quite fast. Yeah, that's probably true of most of this stuff. Alright. So now we're up to 10 people watching. Welcome everyone. I don't see who you are, but say hello in the chat if you like, if you're logged in. If not, anyway, hello. And if you missed something in the beginning and want to see it again after the stream, you can watch the recording. So that's always okay. No, come on. Yeah, I hope everyone is safe and healthy with everything mad going out there in the world. Alright, those were the big caps. Now let's do the smaller ones, because probably it's probably a good idea to do those first, so we don't heat up the chips too much. But I guess the modern ones are not that sensitive anymore. Necroware says, I never had so much spare time in my life. Okay. Do you have kids, Necroware, is the question. Because if you have kids and you are in a lockdown, you still don't have any spare time. Oh, that's not completely true, but they demand quite a bit of attention. Yeah. There we are. And the last one is up here. These are all the bypass. Georgia3 says, I got exactly the same mechanical pump, but it's not as clean as the soldering station. But I got to confess that I'm using 1 temperature pistol solder. Desoldering lead-free solder is then a nightmare. Yeah, I guess. But flux will help. Flux will always help. Or you can add a little bit of leaded solder to make it easier. So this is actually quite a nice board because it's pretty small, not many components. we go. Martin, what is the cheapest station? I think we had that before, right? The ZD915. Where did you buy the board? I'm a big fan of JLC PCB because they are cheap. They make very nice finishes. They do... Oh, this one... Does this one have the chamfered edge? Not really. Very slightly chamfered, but they have pretty decent quality and are pretty cheap. Also, the shipping is very cheap with them. PCBWay, which is very big with some YouTubers, and they have a very big media presence, are usually more expensive. And we have one manufacturer actually right around the corner called Eisler, AISLER. But they have a weird pricing scheme where the bigger the board, the more expensive it gets, but it's like not linear, but it gets really expensive, the big boards. So they have more targeted towards makers who do small PCBs with like ESPs on there or something. I used to use them in the beginning, but the pricing just got way weird. I would like to support them because they're local. I went to their Christmas party basically because they are like a maker community. But they're actually for this kind of hobby, they're too expensive. I'm not able to design my own boards. I tried to change a design for the renovation sound card in KiCad, but I'm a total noob regarding KiCad. I need to read up on it and try to get into that. I'm a coder. I'm not an electrical engineer. Saying this, there is the solder masters going off here at one point. I'm not sure if I scratched that with the iron or with the snips, or if it's just bad quality today. But so far I have ordered maybe 50 PCBs over a couple of projects, and JLC did never deliver crap, so they were always high quality PCBs. And with them, if you're just prototyping, they are extremely cheap, and if you want to have this nice gold finish, etc., they are of course more expensive than with the cheap option, but they are still much cheaper than PCBWay from when I quoted for prices. That might change, of course, due to different rebates or whatever, or I think PCBWay has now this 6-year anniversary thingy. Maybe they're cheaper than for celebration reasons. I don't know. Nekaware says, I'm also a software developer. Yeah, I guess there are a few of us around here. I just looked and the ZD985 is cheaper here and it's compatible with ZD915. I think I might go with that, says Jirja3. How much is the ZD985? Because I would also be interested at some point to have a desoldering station. Let's do the resistor pack now. Martin says, I'm talking about kids. My desoldering station is noisy and once woke up one of my kids. Yeah, of course they're noisy. The pump. The pump is pretty noisy. But that's life. So did you teach your kid how to desolder? Because then you can delegate this boring task. Deirdre says 2100 Czech crowns. And now somebody please Google how much euros 2100 Czech crowns are. Because I don't know. I know that 10 Swedish crowns are €1, but that's about it. I guess the Czech have a different crown than the Swedish. 78.60 in euros. Okay, well that's not even that cheap, right? But probably very cheap for a desoldering station. By the way, the ZD915 has a 12 volt fan connected to 18 volts. I modded it. Now it is silent, I guess. It says NecoWare. Which solder I'm using? Yeah, I lost my my sticker, but I think it's the same as this one. Stanol HS10, 1mm diameter, flux core, and 60% tin, 40% lead. Asks David Kane. Next up, sadly I don't have matching resistor packs because they weren't available at Mouser at the time. They were on back order, so I bought a yellow one. And I think I bought the yellow one, I bought even here at my local electronics store, because for some reason all the resistor packs at Mouser were sold out. I'm not sure who made a project with probably hundreds of resistor packs. But particularly these were totally gone. Let's see, did we align correctly? Yes, the dot is correct. Resistor packs always have a dot which shows the common pin. On the yellow one it's over here as well, and Sergey marked it with this little line next to the first pin, between pin 1 and pin 2. Okay, next up I think now we can do the ICs, then the LED and the pin connector for the LED. Because for the hard disk activity light, what do we have here? This is a 688. We should have two 688s. Yes, the second one is in here. What is the 688? I would guess that it's probably a address decoder or the bus transceiver. Probably address decoder. I would guess address decoder. Can someone look up 74688? I say address decoder, because I have no clue. And am I too stupid to put it in? I am too stupid to put it in. Bend the legs a bit more. Now it fits. Here we are. Notch is at the right position. One leg. Opposite side. There we go. Okie dokie. Does it look good? It looks okay. A little bit too much almost. It's an 8-bit comparator. Okay, yeah, makes sense. But that's basically for the address decoding, right? Because this will compare probably the address that's sent to the bus to whatever is configured via the DIP switches, and then decide if the command is actually, that's on the bus, is actually for this card or for something else. Are you using HandsKit soldering iron? HandsKit? I'm trying to get this in here in shot, the KSGR T12 soldering station, ordered on AliExpress, because it's a very, 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 very solid station and pretty cheap, and you can use the Hakko tips, and this actually looks like a Hakko hand thingy, but isn't. And I'm very happy with it. I've been using it for quite some time now, and yeah, and of course I'm also trying to do this all in the cheapest way possible, but also with the best tools that you can get for cheap. Started off with a 20 euro soldering iron from Amazon, and I'm still using, like, it came in this bag, it was 20 euros, and it came with these nice tools here, which I still use for pulling chips and stuff. There's my other snips in there, desoldering braid, some little tweezers. The iron is crap, but it was good for learning. I learned a lot using this. The pump was replaced because it broke after 2 years. You got a spool of, no, this is not this, you got a spool of cheap soldering, solder. Yeah. That's what I learned with, and now that I got better, I, like 1.5 years back or something, I bought the other soldering station, and which works pretty nice because I can use different tips. It has it's temperature controlled. It has a probe inside the tip, so it's pretty accurate, I guess. I never test, but also I don't need, because it's good enough for my purposes. And I think it was around 50 euros delivered, 50 or 60 euros from China. Obviously it took a while, and it was solidly constructed. I opened it up and showed it to a friend who's an electrician, and he said, yeah, it's fine. Why do you think the one from Amazon is crap? It's okay for learning, but it is weak. It's only like 20 watts, if it's at that, and it only has this tiny twist wheel at the back, where you can set the temperature, but that often gets, like, you accidentally get onto that, and basically the temperature is then different than what you actually dialed in. Plus the tips are not very good. They oxidize much faster than this. This one actually stays pretty clean, but I did quite a few projects with the old one, so it works, and it's you can actually take it with you when traveling or something, if you need the traveling iron. And I think it was perfect for me when I started, because everything was in there. I could just take that package for 20 euros and get started. And it was very rewarding to do my first blinking circuit, because the very first thing that I soldered was probably not exactly this, but was one of these through-hole training kits where you learn to solder resistors, transistors, capacitors and LEDs, and you can just plug it into a 9-volt battery and it blinks. Very nice. Jirja says, I think they used exactly the same soldering head. They got it on their 4-in-1 machine called HandsKit 935, including soldering iron, heat gun, PSU and USB. Ah, okay. Yeah, I'm wondering if those all-in-one kits are good. I think sometimes it's better to get one piece at a time, spend a little bit more, and if something breaks, you can just replace that particular device. For example, get a separate heat gun or heating station, hot air station, I think it's called, hot air station. And maybe at some point you notice, I'm not doing hot air a lot, and then you can sell it if you don't need it, because it all takes space. So I personally would probably buy separate things. Nicoware says, I'm just asking because I have something similar since 2 years and I found it actually okay, but already thought about to try something else. That's why I'm interested in opinions. Yeah, exactly. If you're starting, it's definitely a good choice. It's easy to use, but having something like this, this thing is also much faster. This is like 60 watts or something, and it heats up really fast. It has, I think it's based on an open source project. It has lots of functions in the station, and as I said, you can use, if you want not to use the no-name Chinese tips, you can buy the Hacker brand ones where one tip will be like 20 euros or something, but they will be very good and they will last for quite a time. But so far I didn't need the Hacker branded tips, but it's nice to have the option. So let's do the 74LS32. Cleaning up. So this is the last but one IC. The last one is a 74LS04. And if I should have to guess, I would guess that's some kind of flip-flop or something, because it has a very low number. The one I have maybe is slightly better than what you have from Amazon. Mine is 60 watt as well, but still maybe I can try something better. Yeah, 60 watt, that will definitely be better. I'm pretty sure mine is 20 watts and it's pretty slow. Yeah, and having 60 watts is, I think, pretty necessary for a lot of projects. Otherwise you are waiting and waiting and waiting until it heats up, or it gets the PCB heated enough so that the solder will melt. Inverter. Okay, it's an inverter. But what does it invert? I should definitely learn what the 74 ICs do, but then again, since I'm not designing anything, I probably don't have to know. But I think it's very nice that TI still produces all the 74 series. It's definitely excellent for us retro people. So we've got all the ICs. Now we only have the dip switches, which are expensive. Those were, besides the compact flash socket, which is around 3 euros something, I think. These are very close behind. Yeah, I mean, there are probably cheaper ones out there, but dip switches are terribly expensive. Necro says maybe it's just used to TTL to CMOS stabilization. Okay. Why do you need an inverter for that? Or is it like it inverts it twice? if you send the same signal through an inverter twice, you can use it like a driver. So, oh, yeah, that sounds plausible at least. That could be a reason. Could also be a reason why they use a hex inverter, because they only needed more than one signal stabilized. But maybe it just drives the LED. Could be. Maybe some line goes low when the hard disk is accessed and they just need it the other way around, maybe? I don't know. I have no idea. So, what do we have here? Looking good, I think. Yeah, I think it looks okay. What do we do now? The second dip switch, I would say. There's documentation on the back, but sadly, parts of it are riddled with holes from the ICs and the dip switches. But we can just copy the settings from the other card because it will work. Also, the EEPROM is the same. Come on, come on. Yeah, looks okay. Good enough. Damiano S asks, what is? Probably talking to Necroware. I said that the hex inverter here is probably only for driving the LED, maybe. And Necroware said, could also be. Or maybe you're talking about something different. So, where's the flat side of the LED? Here. Quick quiz, long leg cathode or short leg cathode? Who knows? Because that's another thing that I can never remember. That's because I don't have to deal with them daily. LED is in place. Now for the most expensive part that does actually very little, the pin header. I won't use it, so I could have just skipped it, but it's nice to have it in here. Long is plus, short is minus. So short is the cathode. Long is plus, okay. Everybody knows. Good people, good people. Ouch, burning my fingers because I'm holding the pins of the pin header. It was not very clever. But it's only for a short time and it's for the greater good. Look at this! Apart from this wonky resistor, I think it looks decent. Not gonna clean it yet. I am going to do two things. I am going to switch to the PC in 1 second, and it looks a bit weird because that was the starting of the stream. And I'm gonna switch on the PC to take a note of the, okay, the PC is acting up, which he does from time to time. Let's retry. No, it still doesn't want to. Retrying. Here it is. And we're gonna make a picture of the hard disk settings because we are gonna replace the hard disk. And I'm just gonna hit, oh, forgot about my drink. I'm gonna make a screenshot. So these are the hard disk settings. And I'm gonna switch off the PC and we'll open it up. And you will just have to wait for a few seconds because actually I can show you what I'm doing, or at least a little bit. I can show you a little bit. Let's go back to, no, not to this. This is wrong. This one. This one's better. Here's the card. Which way does it go? I think it goes like this. Yes. We will see if we can get this to run in the PC. Which VGA grabber are you using? I am using a combination of the open source scan converter, the OSSC, and a very cheap USB 3.0 HDMI grabber device. It's just a silver dongle. It was something like 50 or 60 euros, but it handles the weird resolutions that the OSSC outputs very well. And it does only 60 or 30 frames per second, nothing, sadly no 70 frames, which would be useful for the PC, but it works really good, and both together are cheap enough that I could afford it. And yeah, we forgot one thing. This will not work. This will not work because we didn't put an EEPROM in there. And here are two EEPROMs, which come on, which are actually already written with the correct firmware. Here we go. So we should be able to just plug it in, and it should register with the PC. Yeah, this is the EEPROM. This will go into the PC. So just wait here for 1 second. The PC is right next to the desk. I might have to remove some card from there because it's actually pretty full, the PC. It's almost full with all kinds of expansion cards. Sorry for the noise. And you can already take bets if the whole thing will blow up or if it will work. Honestly, I will just take out the compact flash to IDE adapter. And we will turn off the soldering iron for now, because otherwise it continues to beep. So this is what I'm taking out. This is just a rather passive compact flash. Actually, this will not fit, right? No, this is actually PCI versus, yeah, this is PCI, so it's on the wrong side. Because I only got the blank keystone bracket, and at some point I will need to Dremel out a, yeah, at least a bit of rectangular shape here to be able to to use a proper bracket on there. But this is one of these generic cheap powered, so it has power but pretty passive otherwise adapters for IDE, which works fine. Hi Volker, welcome to the chat. Hi Guillermo, also welcome. I think I know you from DOS Reloaded, I think, or Vogons. Or both, maybe, I don't know. Yeah, I'm gonna put this into the machine and see if it explodes. Or if I can put it in here at all. I'm a bit fiddling around here. Okay, it's in. And I forgot something. I need to pull it out again. What did I forget, people? Why is nobody thinking? What did I forget, huh? There are a dozen switches on this thing. And I need to put them to the same as here because I'm using the same EEPROM. So 3 goes up, then 1 goes up, 2 goes down, 3 goes up, 4 goes down, 5, 6, 7 go up, and 8 goes down. And 8 is, I think, not even needed. Okay, this was the one that I built a couple of weeks back. This is the new one. All right. Let's put it in. Let's have a look. Okay. Woo. Let's switch to the PC. You will see the BIOS screen, but it's not turned on yet. So that's a bit of fake. Okay, it's acting up. This is actually because the VGA card is not sitting perfectly in there. Ah, still acting up, still acting up. Retry. No. I hate you, computer, I hate you. We got something, okay. Fixed disk configuration change. Yes, of course, because I removed your fixed disk. So it will not show up here. It shouldn't, because there's nothing on the primary controller. But I should be able to quit, and we should see at least, yeah, at least we see the BIOS. So this is the XT IDE BIOS that does work. But that's of course a problem, yeah. So the problem now is that the EEPROM is looking only for my internal IDE controller, which is not what I want. But we can and should change that by writing a slightly different EEPROM. And we do that by reattaching the compact flash to the internal controller. Restarting. Okay, stupid machine. Oh, come on, I hate you. Don't let me down like this. The beep codes on the Micro:IT Research are pretty annoying and they're very slow, but this one always says I don't see the VGA card, which sucks because it's right in there. So I'm gonna wiggle it around in its slot. And it's still not wanting to do it. Maybe I'll replace the VGA card just for the time. I have plenty. So, one VGA card out, and I will show you what it looks like in a second. Here we go. Here's the card. Remove the flux on board. Yeah, I will, once it works. And let's grab a replacement card. A bit of a slow one, a trident. So replace with a trident. Time to shout some German swears. Yeah. I probably get demonetized then. No, we don't want that. So, new VGA card is plugged in. Let's hope this one works better. It doesn't beep. That's a good sign. Here it is. It of course says that the fixed disk configuration has changed again. It still remembers the old hard disk parameters, but we need to enable, and that's something I had to learn the hard way, the translation functionality for the bigger hard disk. I don't know why it's not done automatically for the large hard disks, but that's like it is. So the XT BIOS tries to do something, but it should not. Yeah, okay. It doesn't do it. I have a tool here. Where did I put it? Here, Tools XT. There is something called Flash, I think. But I think this here is the right one. XT config. We want to use this one here. This is the correct one, I think. Is flashing actually enabled on my card? Flashing enabled when 2.2 is on. 2.2 is that one, and it's actually off. So let's flip the switch very carefully. Okay, flipping the switch was a success. Now we need to configure the BIOS. We want to use the XT CF. Which one? I think it's the XT CF Lite in PIO mode. And which address? Let's see. We put it to 001, which in turn is 3CO. Okay. 3CO is the hardware address, the base command block address. And that should be it. Now we should be able to flash the EEPROM. So which device do we have? We have a 28C64. Yeah, that should be about correct. Okay. SDB command, software data protection. I don't know. I have no idea. EEPROM address is What is our thing set to? It's set to 1 0 1 0 1 1 0 1 0 1. Is that correct? 1 0 1 0 1. Oh no, it's switch 2.3. Okay. Okay. I'm looking at the wrong switch. Switches can be changed while PC is running. I think so, because they are basically hardware switches. So the EEPROM write enable will just take away the plus 12 volt or whatever is used for programming. So that's definitely possible. It's maybe not advisable, but I think it's possible. So my address is actually 0 1 0. Oh no, my address is 1 0 1 1 1. 1 0 1 1 1. And that should be the correct address that we already had here, D00 hex. Okay, let's try. Oh no! Sadly, it's not correct. Maybe the SDP command? Yes! That was the problem. Haha. Press any key to reboot. Actually, no. I'm going to turn off the machine. Put the CF card in to our card. Turn the machine back on. Now we have the Trident BIOS, and it will beep because the disk configuration changed again, which is fine. We just say, okay, you're right. And it still tries to boot at 300 hex, which is wrong because we are jumpered at 3C0. But we can re-jumper. For some reason it uses the wrong address. Let's punch in a different address, but for that I need to remove the card. I can't see that well. So the switch block 1 is for that. So it needs to be put to 1 1 1 actually. Yeah, now we have it at 1 1 1, which should be 300 hex. And I'm wondering if that will conflict with one of my sound cards, because that could also be... Oh good lord, does it do anything? Because I'm wondering if if the PC MIDI card is actually listening to 300 hex. I'm not sure. It doesn't boot. So the BIOS works, the booting doesn't, which does not necessarily mean that we did a bad solder job. I will start removing cards now. Because I think the PC MIDI card might listen on 300. Not 100% sure about that. So let's try without that card. I found the flash tool of XTID to be not quite reliable. It often says that the ROM was flashed, but it wasn't in real. Okay, Necroware, what are you using instead? It doesn't look good. 300. Okay, that didn't work out. Let's try the flashing again. Martin says, Necroware, that might happen when the system BIOS shadows the ROM. That's actually definitely a problem. We can have a look, because the Microid BIOS here has shadow options, and okay, there's read-write shadowing, write protect shadow, and okay, the read-write shadow. But that should work, shouldn't it? Maybe we just do it like this. Neckware is using the TL866. Yeah, I was using the Gallup 3 actually for programming the initial ROM, because the empty ROM was not even visible thanks to the microid BIOS. But let's see. I'm gonna try with this. Oops. I need to turn on the translate again. The shadow is now set just to ROM number 2 because it detected that there's a ROM. The ROM is seen and executed. Just for the sake of it, I will try to rewrite the ROM and to put it to 3C0 to be sure that something more or less useful is happening here. So let's again. That was stupid. That was the wrong one. This one here was the right one. Load BIOS from file. The ID XT CF4. Configure. The ID controller is supposed to be this one here. Base command. Let's try it with 3C0 so that we see that it does something. And then we're gonna flash. SDP had to be disabled. EEPROM address should be correct. And we start flashing. Okay, let's reboot and let's see if it now has a different base address. It doesn't. That's very interesting. Any ideas, people? Because at the moment I don't think that our soldering skills are the problem. I think I had the similar problem with the other card. We can try a different. I think I also have different releases. This one was the BIOS that Sergey actually had in his repository. But we could try like the ID XT BIOS. It should be an 8 kilobyte. This is one of the larger ones. We can't do that. I think this one should be possible as well. Let's try to write a different BIOS. Let's take the ID XT. Which machine is it? What do you mean? So that should be fine. Flash EEPROM, SDP, disable, start flashing. Oh, now this takes some time. That's interesting. It didn't take that long before. Maybe it didn't flash anything. Yeah, it's a 486 actually, Neckware. But XT BIOS should still work, I guess. Let's see what the BIOS says. Now we get 3C0. That's interesting. I think we should try to put in the compact flash card now, because I think now it might actually boot. Okay, let's turn off the machine, swap the cards. Turn the machine on and see. XT BIOS should not work. Why not? Explain to me. So fix configuration, fix this configuration change, we know that. Why should... Oh, it doesn't work. It does not work. Not found, it says. Not found. Very sad. Very sad. Interesting. Neckware, do you have any reason apart from that it's actually not an XT why it shouldn't work? I thought that the AT version just uses like 16-bit instructions and stuff, but was basically the same. Let's enable the hard disk again. Because of the addresses. Which addresses? I would like to know. But we can try for sure the AT thing. The address space has moved ID addresses. Okay, not sure about that. But we can try for sure to use the other one. What do I want? XTID here. Okay, let's try again. He says we should use the ID AT BIOS. Okay, let's do that. Configure it. Primary controller. What? Device type 16-bit. No, actually we have something like that. And we say we have 3C0. Kilobyte to steal from RAM. Okay. Yeah, do whatever you like. ID ATL, I can't use that because I only have an 8 kilobyte EEPROM, so that's a no-go. The L has, I think, only additional menu stuff, etc., but it should be more or less the same functionality. Yes, go. But what's definitely more promising is that the flashing now takes much longer. So one thing that we could do is, I'm pretty sure that the other card works perfectly fine. We could try the other card, but actually of course I wanted to show that this one here works. Which BIOS should I use on a 286 plus TVGA? Guillermo, I think, as you can see, you can just try out any and see if it works. I was using for over a year the BIOS that Sergey actually supplied in his repository, which is a slightly different version than this. I'm not sure about the differences. One quick test if the BIOS works. And I think still think the XT versus AT part is merely due to the usage of 286 specific instructions, but I'm not 100% sure. What happened now? I think the VGA cable got loose? I don't know. Martin says, yeah, I think changing BIOS setting for shadowing helped. Yeah, that probably helped. I have not high hopes. I'm not sure why the card isn't seen currently. Now we get the beep because the hard disk changed. I now put the compact flash card again into the XT controller, and I just have to press F10. Nice color change, yeah. That doesn't look good. Yeah, the color. What's with the color change? Tries to boot from A. That's weird. That's a weird color change. I think we have to have another look at the card itself. Do a double check. So let's put away all the non-essential things. The address must be 1F0. Okay, if you say so. 1F0 is not possible. I can select between 300 hex and 3E0 hex. That's what I can do. And this one here is, I think, the old one is 001, which is 3C0. Oh, this one here is a 3C100. Oh, of course this can't work. God, I'm stupid. Okay. Now it's 001. Okay, now it's 3C0. Shall we try it? It might just work now. Hopefully. Hopefully. Okay, I should put it in the right way. Come on. Where's the slot? Let's switch over to the PC with the funny colors, and let's hope that it works now. I want to show you a working card. Come on, come on. Oh, doesn't look good. Doesn't look good. No. And this BIOS, for some reason, when it fails, it switches the colors. I have no idea why. Okay, this is weird. I'm almost about to give up. Does anyone have any good ideas? I'm open to anything. I personally would now try one more time the Sergey BIOS. Neko, I think you might be right, but I think it doesn't matter much, because even, I mean, the XT isn't magically different. I think as long as the ports are not taken by any other card, that should be fine. Because, I mean, we're running our own BIOS here. I think that should be okay. I'm gonna try the Sergey BIOS one more time, because I had luck with that in the past, that it would work. This is already correct. So let's go back to the main menu. Which BIOS is on the older working card? Actually, it should be, I think it's Sergey's BIOS. So that's why I'm also trying to use that. Let's hope that it works. At least it takes again more than half a second. Let's see if it makes any difference. Well, it takes pretty long. But I mean, if it's writing byte by byte, it's probably makes sense. Yeah, there should be an auto-detect function. That's correct, there is an auto-detect function. How it is with BIOSes made before year 2000? Well, my BIOS is from 1991, so it should work. And I mean, it's the XT IDE, so it's actually made for very old BIOSes. Swapping around the card. Switching on the PC. So straight into the. Okay, here we just have to press F10. And you see, you can't change the address for that. Okay, so there's definitely something weird with the Sergey BIOS. Tom van Mill says AT has the same address space as XT and more. Yeah, that's what I was thinking. Some supposedly had problems with year 2000. I saw a video from one guy. Yeah, actually, a lot of BIOSes are pretty year 2000 compatible. Physical address should be modified to 302. Yes, of course, but actually we try to write to so that it uses 3C0, but I will change around the jumpers or the dip switches one more time to 111. 111. There we have it. Reseating the card if possible. If possible. Yes. Switching on. Can you put the working card into... Yeah, I will try. I have to remove the bracket. I think it was working. Maybe I was dreaming that. Yeah, it doesn't detect the compact flash card. That's annoying. Maybe we have a problem with our socket. Let's try the other card. Removing it, the old card that is, the new card. Swapping around the CF disk. And please turn the PC off so the BIOS can reinitialize all the address space itself. Yeah, of course. You're just seeing the screen still because my capture card just reads out garbage. So the PC is off, of course. Okay, now we have the old card that I soldered a couple of weeks back. And does it see anything? Not really. Okay. The question is why? Is there a different problem maybe? I'm pretty positive I had this running. Maybe not in the 486. That's a tiny bit annoying actually. And I'm not sure I'm gonna solve it today. Let's switch switch off the machine, pull the card. So we have two cards now. Oh, this one actually is wrong card, jump out wrong as well. So this could not work. Let's try that second card again, because we didn't do that. It can't work. It is XT BIOS with 300 address. I don't believe you, Nico. I don't believe. This card works. It might be an issue with the address space that could very well be used already. Yeah, I'm gonna pull a bit more cards after this last try. I'm gonna switch to the PC. And if that doesn't work, I'm gonna pull out the... look at this. Ha! I knew it! I knew that I had it running. So this is the old card. And as you can see, it works on 300 hex with the XT IDE BIOS. Whew! Okay, I was not completely crazy. Which means that our soldering job might not be that perfect. Maybe I have to retouch it. And I was so sure that I could do this job a second time. Seems I couldn't. Yeah, but I hope you guys believe me that it does work. The question is, will I try to touch up the thing and try to run it, get it run today, or skip it? Because we are, how long have we been doing this? Not sure. Almost 2 hours. Yeah. Let's quickly see Dr. Hardware. What it says about the card. Quick start. And yeah, okay. Shareware. Not sure if I can still buy something. Benchmark. Hard disk. Let's see if we can get a test for software caches. Yeah, please. Track to track access. Mid. Let's see if it works or if it crashes. I had some hard disk benchmarks crashing on the CF cards. I'm not sure why. Yeah, this might be hanging. Because probably the CF card is too fast or something. But I would say it definitely works. The question is, why does the other card not work? Parallel port configuration change? What? You are lying. Thing is lying. It's lying. You're not seeing anything, so I'm gonna switch back to this. I'm gonna say we're doing one more try. I'm gonna try to touch up the solder joints on this card's CF connector. They do look okay, but probably not good enough. I'm gonna add a little bit more flux to avoid solder bridges. I'm gonna put a little bit of flux of solder. Yeah, Tom, you're right for sure. A little bit of solder on there, and I'm gonna run over this, and I made a bridge which I will have to remove now. There was not enough flux over there, I'm saying. It's definitely a very difficult thing to solder. There's still two bridges. They were not there before, no worries. I just introduced them. Replace the ROM chip from the old card to the new card. Yeah. David says, yeah, okay, yeah, David is correct, but first I need to fix this. Because with the solder bridge, it won't work at all. The problem is that the legs are very close together, and the orientation on the transistor packs, yeah, I double checked that. That's all good. We already checked that early in the stream. I need to get some wickety wick, because I made a stupid blob there. That's always when I try to repair something and make it worse. This looks better. This looks actually pretty decent. Okay, I think I'm happy now. The solder bridge is gone. There's a decent amount of solder in front of every leg on the pads, so I hope this will make good contact. Let's take it for a spin. Let's go back to the PC. No, there we are. Turn it on. Why are we not seeing anything? We are not seeing anything. I'm not sure why. Let's turn off the PC. Let's turn off the PC. Am I in the right? Yeah, I'm in the right thingamajig. VGA cable is in. Why are we not seeing anything? The PC is beeping. It is working. Let's cycle the OSSC. There's the OSSC. It has no sync for whatever reason. Interesting. Did this video card give out? That would be the luck of today. We have all the broken video cards. I'm gonna swap it out once more for the Tseng, because the Tseng was actually working pretty nice, but I suspect that this ISA slot is a little bit wonky. But that's old hardware. Always a bit fiddly. Nope. It is on, but it is not showing anything. Something is bad. When we check the ATX to AT adapter, it says we are taking 3 amps on plus 5 volts and 260 milliamps on plus 12, which is fine, so there's no short. But I also don't hear any beep or activity, which is not optimal. This card should work in both XT as well as AT PC with the same ROM, right? Necroware, I think that's correct. I'm wondering I'm on the right channel on the OSSC. We are on AV3. Yes, we are. I'm going to pull some more cards. So the good thing is my machine has the ATX to AT saver. I'm gonna show the desk again so you're not bored too much. No picture. Yes, exactly. So I'm gonna just basically pull out all the cards, the IDE controller. I will leave in the VGA card, obviously, so we see something. And the good thing is I have the ATX to AT adapter, which detects shorts and stuff like that. So even if we did make a mistake, we shouldn't destroy anything. No, the power supply is good. The ATX to AT reported the normal amount of stuff. But this way you can see all the cards that I have in here. This is the Goose R Homebrew Gravis Ultrasound clone. This is the Snarkbarker Sound Blaster Homebrew clone. And last but not least, the Tandy. Alright, now I'm down to only our XT CF card and the VGA card, actually. Let's switch back to the PC and cross our fingers. There's a beep, but no sync. Why do I have no sync? Let's pull out the XT card, because that's the only thing that could... Ha! We've got a picture. Which leads me to believe that there probably is still a solder joint, solder bridge in there, perhaps. Or why else would it be no video when I put this thing in? Let's put it in without any card, any compact flash card. Troubleshooting. Multimeter. Yeah, the problem is okay. There's no picture when the card is in. Interesting. Actually, the multimeter, I tried that before with the very old card, where I had even worse soldering skills. And the problem there was that, first of all, the contacts are tiny. Second of all, I had the impression that continuity didn't help, because there is continuity between pins, even on a good card. So left is the good card, right is the bad card, okay? Let's put the compact flash card into the good card. Let's put this to continuity. Now we would did something warm up a bit. No. Also, as I said, the ATX to AT converter didn't show any excess current. It would also shut down if there was like a short circuit, or if more than the allowed current was supplied. It's actually pretty good, this device. For people who don't know it, this is the magic device. It is called the ATX to AT Smart Converter by Mr. de Meulemeister. His address is x86.fr. And in goes the ATX power supply, or in goes a special power cable, and out goes the ATX power, basically. Actually, no, I'm talking garbage. This is the ATX power supply, comes in here. Here comes the AT power out with a custom cable that he also provides. And it protects your old PC against any overcurrents. And Tom says, I've made a great video about it. Thank you. Yes, I did. And I love this device because it saved my ass already a couple of times. So yeah, but we want to check for continuity, I guess. But probably shouldn't, while measuring, have the card actually plugged in. But if I go here, swiping across this, you noticed there's continuity between some pins, even though this card is good and has no bridges. So it's actually not the best thing to have. Furthermore, I'm wondering why I get continuity when I'm here. Not sure if it's a ground pin, because from the traces on here it looks actually to be not connected at all, I think, but not 100% sure. So measuring here two neighboring pins, for example, now I'm at 1, 2, 3, 4, 5, pin 5 and pin 6, it says it's connected. When I go here from 1, 2, 3, 4, 5, from 5 to 6, actually it says it's not. That might of course be a problem. Maybe there's a problem here. Okay, I think we found at least one problem. So, Guillermo, you can laugh at me because I think Guillermo also had problems soldering this thing. And now I'm the stupid one who can't solder, which is not surprising at all, to be honest. The question is, can we pull out the solder from there? Because who knows where this seeped through. Maybe it even got under the connector or something. And that would be not good news at all, right? Other than putting more flux in there and heating it up, I don't know what exactly to do. We can just try to put a bit more flux on that particular area and heating it up again to reflow. But it might be necessary to... Yeah, the problem is, this is I'm not gonna say it, something nasty to desolder, because you have tons of pins and you won't get them all off at the same time. Neko says you shouldn't blame yourself, it's life and such things happen all the time, even to the best of us. Of course, to the best of us, yeah. That's true, but it's still pretty annoying that things like this happen. So I'm gonna reflow this here, try, and I made it actually worse in the right when I try to make it better. I'm gonna take off a bit solder. I'm just gonna use my wick, wickedy wick. And actually I need more flux because the wick is also taking up the flux. Oh boy! Yeah, Guillermo's feeling with me. It's a nasty little card. Isn't there something that is able to use SD cards that we can build? because I think an SD card connector is so much simpler. This is so nasty. But I also find it very interesting that having these pins bridged leads to the VGA card not displaying anything. That's pretty interesting error condition. It's a very weird side effect. Okay. Let's check again. Nekuware says, I was searching once for XT IDE but without the CF socket, just a plain IDE port. Just because of this, SMD soldering hell. Yeah, of course. But still, why I wanted this card is because I have an externally accessible CF card. I can turn off the computer, pull out the CF card and put something on there. That's actually pretty useful. And yes, of course, I have this weird adapter, but for a smaller build where you don't have so much space and stuff, this is actually a pretty neat card. And I mean, I have one working one, so that's at least a 50% success rate. But yeah, so let's check pin 5 and pin 6. I think Sergey designed this just to annoy people. 1, 2, 3, 4, 5 and 6. Bummer. I'm thinking the solar bridge is underneath there. I think that's underneath there. Guillermo says, DOS Reloaded member helped me out with Solder Honey to get rid of the shortened contacts. Oh, that's nice. I'm not sure how to proceed on this. It's approaching 11 o'clock here, so I will do one more try removing this bridge, which is probably under there. Question is if I should feed some flux from the top, but I fear that I nasty up my contacts here and then nasty up my flash card, which I don't have to insert. Yeah, but I have not the greatest hopes that we will make it today, because here all the pins look fine. I don't see any bridging here. So I think that might be right underneath the connector actually. And I think this one you can only get off with hot air. And probably you will destroy the connector in the process if you're unlucky. This I can remove, but this here, no chance of heating this up. Or you have to have a huge iron, like one of those things that you can use for desoldering whole chips or something. Could give a try. Could give what a try. So let's double check here if I was correct about the pin 5 versus pin 6. 3, 4, 5. 5 and 6. 6 and 7. No bridging there. What is Solder Honey? I think Solder Honey is very similar to this tacky flux that I'm using. probably a different name, maybe a slightly different compound. So I have between 5 and 6, there's a definite bridge, and 6 and 7 as well. The question is why? One last try, heating up a bit more. I'm gonna put lots of flux on there to hope that it evaporates not too quickly. And I'm gonna heat up those pads and hope that the solder flows out. Not sure if that will actually work. I'm just gonna heat up the pads. It's fuming away. Fuming, fuming, fuming. Okay. Let's try and measure. 1, 2, 3, 4, 5. No. Even between 5 and 7 there's a bridge. Yeah, it must be very deep under there. That's too sad. So we have a partial success for today. You had your amusement, I think. We have one working card, this one here at the bottom. Actually, I don't need to mark it with the card because this is full of flux, this isn't. And this got the crooked resistor. But I was hoping that I could replicate my success with this card. It seems I couldn't. I think at first the problem was simply that I didn't have good enough contact to the pads. That's probably why we didn't see the card recognized. And then I made it worse by creating solder bridges, which are very hard to remove now, if not impossible. There's even not a way to look under there, I think. Yeah, so I think this card is half lost. Maybe at some point in the future I will revisit it. But for now, I actually had enough of this card. I don't necessarily need 2 cards because my 486, as you have seen, can run just fine without it. This one is here more for the 286 board that I have that I'll sometimes take out of the package and use. And I don't necessarily need the second one. But of course, perfection necessitates that I at some point revisit this and try to fix it. But that might be some months in the future when I feel more confident about that. I think I won't get around desoldering this, probably getting a replacement connector, which is again €3 something, and I need to pull it with some other components that I buy. But for today, I think this is a partial failure or a partial success, either way you see it. Yeah, next up will be dremeling a hole into one of the brackets so that I can actually properly mount it. And other than that, next video will probably be another Let's Code video. Maybe also something C64 related, but who knows, whatever I'm up to. Maybe I'll do another live stream in the next weeks. I was very happy that 10 people also were every time in the stream, which is very nice. The chat was very lovely. I thank you very much that you were here. And yeah, I hope you have more success assembling your things, or maybe you learned something that you don't want to assemble one with a compact flash socket, because the failure rate is too high if you're not some soldering god. And other than that, I hope to see you soon. If you aren't subscribed yet, please consider subscribing. We're nearing very, very quickly the 1500 subscriber mark. Yeah, all the other razzle dazzle, like, subscribe, share. Sharing is actually pretty nice because then other people know about the videos. Thank you again, Martin, for the small donation. It's always welcome because I have expenses, and those €2 will definitely go into some form of equipment or other. If you can't support me in that way, that doesn't matter. We had all fun here very much. And yeah, I wish you all a very good night, good morning, or whatever is on your side of the world. I would normally close with some music from the 486, but I ripped out all the cards, so I won't this time. And yeah, I can only say see you hopefully in the next video. Have a very nice evening.